Hi, everyone.
Hi, Professor. Good morning.
Hello.
Morning.
Good. So we got a lot to do today. Let's see, but I think we have actually another day next Tuesday as well to finish up attention. But I got a list here. Let's see. So the first thing on the list, the test. So I thought it went pretty well overall. There was a pretty sharp curve on it, which is okay. So it was a little more difficult than I would like, but that's all right. You know, the curve moves everything up. And so some people totally crushed it and did really, really great. By and large, I think people are doing well. There are a few that struggled with it. And so I'd encourage you to talk with me about it. I could talk, you know, we can't go over the tests in class, but I can talk about anything you guys want to talk about on the test. You can go over every question if you want in an office hours. So I'd encourage you just to email me and we can set up a time. So it's not, you know, this is my job. So you're not asking for a favor or something, that you paid for this. And I like doing it. I like talking with you guys. And for the people that are having trouble, I'd like to do what I can to help out and, you know, help you get better at this. And so that leads to the next part. So the midterm grades, they should all be up. And I think that they all transferred to UTSA. So we should be good with that. Now, keep in mind, so some of you also, you may look at that and go, oh, great. And others are like, I kind of want to do a little better. Almost all the points are still on the board, ready to be put on the board. And so I intentionally designed this course that way, so people won't get into a hole early on in the course or even in the middle of the course. So just as a refresher, you've got 9 quizzes. I believe this was the 5th quiz. Only 5 of those 9 will count for the final grade. So if you're not happy with your quizzes up to this point, only 1 of them actually counts towards your grade. So you have 4 more opportunities to get 100% on your quizzes. And the same thing for the test. So if you look at the test, the first test, and you go, ugh, you know, I wish I did better than that. You have another test, and that's the one that could count towards your final grade. So remember, we dropped 1 of the 2 tests. And then of course there's the final exam. So I didn't add up all the percentages, but almost all the points are still out there for you guys to get. So if you're having trouble, I'd encourage you to, you know, we can fix it now, and then you can end up with an A, you know, for just about everybody, if not everybody. So yeah, so let me know, you know, just, I don't have office hours like a time, just email me and then we'll set up a time that's convenient for you. And let's see, so that's about it for as far as the tests and grades go. Let's move on to the quiz today. Or maybe I should ask, what does ELOO mean? Somebody wrote that.
I think it's just a typo for hello.
Hello.
Oh, okay.
Or if you want to like Jacob say it with a British accent. Hello, love.
Hello. Okay. All right. Yes. See, I'm just, I don't keep up with these things. I'm actually terrible with texting, which is probably unusual for just about every human in the US. But yeah, I just don't keep up with this. All right. So let's see. We need to move over to the quiz here. Sorry, here it is. I had a bunch of stuff open. Okay, hello folks, here's the quiz. All right, so today we're gonna be talking about one of the most, for most of the day, if not the entire day, we're gonna talk about one of the most fascinating, bizarre neurological disorders out there called spatial neglect. And we'll get into all the details soon, but it's very bizarre because it calls into question, or at least raises the question of how do you know what is out there in the outside world? And here we have an example where people are literally not aware of large chunks of space and what's happening in that space. So a lot of these questions focused on that or related to it. So for the first question, a person with spatial neglect syndrome just means that there's more than one problem that they have. So we're going to focus on several aspects of the problem, but one that we're not going to focus on so much, this isn't the question, I just want to share it with you, is that these people are unable to sustain attention very long. So for a lot of the experiments that I'm going to present to you with people with neglect, they're very short because they can't focus on the task for more than 10 or 15 or 20 minutes at a shot. which is interesting. So we're going to focus a lot on spatial aspects of hemi-neglect, but another part of the syndrome is this vigilance deficit, this inability to focus attention for very long. All right.
So how does that differ from people with attention deficit disorders?
It's a lot different, actually. Yeah, maybe I'll write that down and just remind me. I think later today when we get into what hemi-neglect is, then we can contrast that with attention deficit disorder. That's a really good point. Yeah, because there are similarities but a whole lot of differences. All right, so a person with spatial neglect, usually they have a lesion in the right inferior parietal lobe, and we'll get into kind of specifically where that is. That's kind of like neglect central. So if you have neglect, there's a good chance that that's where your lesion is. But it's possible to get neglect with lesions to other parts of the brain as well, but that's like the most common area. And if you have a lesion in that part of the brain, there's also a good chance you'll have neglect, but it's not a one-to-one thing, right? So there are people with lesions in that area that don't have neglect, and there are people with neglect that have lesions in other parts of the brain, but it's the area that's most common in people that have neglect. All right, so they don't ignore stimuli in the middle part of the visual field where you get overlap. It's actually usually the left side of things. The left side of the visual field is a common example, but as we'll see, it gets even stranger than that. You can have, for example, neglect to the left side of memories. How about? Stay tuned, we'll get into that. And it's not C because they're not delirious. In fact, they can't be delirious. If somebody was suffering from delirium, that would call in the question whether or not they actually have neglect, or at least make it difficult to make that case. So for A, you wanted to go with B. Question 2, which doesn't happen in Balint syndrome. So the 3 main symptoms of Balint syndrome, they're oculomotor apraxia, optic ataxia, and simultaneous agnosia. We're going to go through all kind of the specifics of that later today or maybe on Tuesday. The one thing that doesn't occur in Balint syndrome is apperceptive agnosia. So that's that high level visual deficit where people have difficulty recognizing things. People with Balint syndrome, if they're able to attend to the thing you want them to recognize, there's a good chance they'll be able to recognize it. So if you had them attend, for example, to a chair, they would say that's a chair. Their problem is they may not notice that they may not attend to the sofa and the table and other furniture in the room. They would be attending to just one object. So we'll get into the details of that. So apperceptive agnosia was the one that was incorrect here for number 2. All right, the premotor theory of attention. So this is an intriguing idea that attention, especially covert attention, as we've been studying it, right? So in these experiments, you have people focus straight ahead, and you tell them to voluntarily shift their attention to one side or the other. So it can dissociate the position of where your eyes are in space from the position where attention is in space. But I briefly mentioned that typically the location of the eyes and the location of visual attention are one and the same, that wherever the eyes are focused in space, that's where attention tends to be directed in space. There's maybe an even deeper relationship, which is what the premotor theory gets into, which is that moving the eyes around requires motor programming, and maybe attention also requires motor programming. So answer A is what you wanted there. It's not B, shifts of attention are always followed by movement, because you can get these shifts of attention even without movements. So that's why B isn't correct. And saccade programming is unrelated to covert visual attention. It's actually the opposite. That's what premotor theory is. Saccade programming is part of visual spatial attention. So for 3, you wanted to go with A. Question 4, preparatory bias in cued attention studies is what? So it's only present after a visual target. Actually, it would occur before the target is presented. In our cue target paradigm, this preparatory bias is set off by the cue, not the target. Triggered by cues that are not attended. No, actually, so you need to get that information from the cue in order to set up this preparatory bias. So that's why B isn't what you want. And C, it's demonstrated, you can see these preparatory biases with event-related potential measures, so EEG, functional MRI, as well as single unit recordings. So you want to go with C in question 4.
So for C, you want to check to see where all of that energy, such as blood flow, electronic pulses, where they're going towards in the brain.
Yeah. So you can find areas in the brain whose activity correlates with this preparatory bias. When you cue people and say, okay, shift your attention to one location in space, certain areas of the brain show greater activity, excuse me, and that activity can be measured using different methods. So event-related potentials and fMRI and single unit recordings. Yeah, and there, especially networks in frontal and parietal cortex, which we're going to talk about, seem to be very important for this preparatory bias. It's a network called the dorsal attention network, and that's another one. We'll stay tuned on the details with that. Let's see, for question up to 5, attentional reorienting. Let's see. So that wouldn't be occurring to validly cued stimuli, answer A. Typically, you would get this reorienting when for the invalid trials, right? So when the cue says attend to the left, but then the later target shows up on the right, this reorienting would happen under those circumstances. So it's and it cannot be demonstrated using fMRI. Nope, actually, that's one of the main areas that we can demonstrate this. And this dorsal attention system and ventral attention system, the complementary attentional system, show this with fMRI. So you want to go with B there, which involves activation of the ventral frontal parietal system. It's another term for this ventral attention system. So 5 would be B. All right, visual search. So we talked about this before. We introduced it. I think this was maybe when we talked about the visual system, actually, or maybe it was the beginning of the attention a couple weeks ago. I forget. But in any rate, visual search, where you have them searching for a target on a screen with a bunch of stuff on it. There's a target sometimes there isn't, and there are a bunch of distractor images on the screen. So visual search is generally slower as you add on more distractors. The exception being that if there's a pop-out effect, we're not talking about that here. Is slower with only one featural difference. No, actually it's faster, so that's the pop-out effect. And A is faster with more distractors. No, distractors generally slow things down. So the best answer here for 6 would be B. 7, during visual search with pop-out stimuli, there's an event-related potential that's correlated with that pop-out. And it's called the N2PC. It's a little cryptic, but the N2 stands for the second negative peak, and PC means that it's posterior or parietal, and it's contralateral to where the stimulus that has the pop-out effect is. So if you're looking at a visual search screen, there's a bunch of letters on it, let's say, and all the letters are colored green, except for a red color on the left side of the screen. You'll see this N2PC over the right part of the cortex, parietal cortex. So that's the relationship. But again, we see this backwards relation between the visual field and the wiring in the brain, where you have this contralateral association with vision. So for 7, you wanted to go with A. The P1 and the N1, those are components that of the event-related potentials that are affected by attention, but they're actually usually larger for targets, not the non-targets. So that's why you don't want to go with B. And this negative waveform in C that lasts about 300 milliseconds, that's usually not there for pop-out stimuli. That's there when you're voluntarily attending to one region of space, and you get this enhanced negativity for stimuli at that region. So for 7, you wanted to go with A. And then lastly, the default mode network. So this is another one of these networks that are shown in resting state fMRI that we talked about. So I already mentioned the dorsal attention network and the ventral attention network, sometimes called the salience network. The default mode is yet another one of these networks. And these are areas of the brain that, interestingly enough, are more active. That is, there's greater blood flow in these areas when people are just chilling out in an fMRI scanner and not doing a task. So before they would do, let's say, a visual search task, these areas of the brain in the default mode would be more active than they would be during the visual search task. So that got captured a lot of scientists' imagination on what this may be indicating. So with that, you want to go with A. It doesn't include the anterior cingulate. That's associated more with doing the task. If anything, that has an opposite correlation with the default mode network. So when the default mode activity is high, anterior cingulate activity is relatively lower. When you're doing a task, typically the anterior cingulate activity goes up and the default mode network activity can go down. So that's why B is incorrect. And C is a set of brain areas for demanding cognitive tasks. No, it's actually, we're really undemanding, where you're just lying in a scanner, not doing anything. So for 8, you wanted to go with A. Are there any questions about the quiz before we move on?
I have a question about number 6.
Uh-huh.
In the book, I was reading about how for pop-up stimuli, it doesn't matter how many distractors you add, it doesn't make a difference. And it's for conjunction ones, like if you add more distractors, it makes it harder.
Right. Yeah, so with this, the way this question was written, I think B is clearly the best answer, but I want to write it better because it does blend together these two different ideas, right? That you had the feature search and the conjunction search that we talked about. So really, I think it'd be better if it said conjunction visual search would be a better way of saying this. But like I said, with C, it's C can't be correct because the pop-out effect is that you're faster when there's one featural difference versus when you have the conjunction search. And visual search is never going to be faster when you have more distractors. It will always be either slower or not show much of a difference. And even with the feature search, there usually is a bit of a, remember we looked at the data, there was a bit of the reaction time did get, I'm looking from your perspective, as you add on more items in the array, it does get a little slower like this, but with the conjunction search, it gets a lot slower. So even that, it does technically it does apply to both search tasks, but it's more evident with the conjunction search task. Does that make sense?
Yes, because I had chosen C because I was thinking like if there was a green tea and also like an orange tea, you're gonna pause for the any tea, even if it isn't green or something, if it's like off by color.
Yeah, and it's good that you're thinking about that because there is a literature, we're not going to talk about this in class, where you have people do visual searches. I think I alluded to this earlier. Visual search it's like this industry that there are labs that just do visual search studies for like decades at a time. And so there are lots of variations on this task. One variation is when you have people searching for a target, let's say it's based on shape or something. And then if you have another feature that's not related to the target decision, so let's say color. Under those circumstances, when you have a distinct color there that's not related to the target, you can get exactly what I didn't notice who was asking, who brought up that point. But that's exactly what she was saying, that it can have a distracting effect. I know this is a little kind of a fine-grained distinction, but this is the type of fine-grained distinctions that people make their careers on. That when the pop-out effect doesn't tell you about the target, right, then it can be distracting. When the pop-out effect will tell you about whether a target is there, then it can facilitate performance. And you can get that resistance to slowing reaction time as you add in more distractors. I know that's kind of, it's a little complicated. But at any rate, so the pop-out effects, under some circumstances, if it's related to the task, it can help you. If it's unrelated to the task, it can hurt your performance.
Okay, thank you.
All right, any other questions or comments about the quiz? All right, then I'll stop sharing on this, and then we can get going with the class. So I thought we'd start off with a video of a patient and one of his doctors and his spouse talking about what it's like to have attentional neglect. So instead of me explaining it, let's just have this patient tell you what it's like.
The middle often isn't the middle.
The middle is the right.
You must always eat on the right side, but not the left side. Just leave that.
Give her a dinner plate and you don't eat the vegetables and you leave the meat, which is disappointing because I was a cook.
So if you start to picture, it can not fit in the paper. It gets over to the left because it hasn't left enough room.
Spatial neglect is a syndrome, that is signs and symptoms that patients most frequently have after stroke, but sometimes in forms of Alzheimer's disease, where they ignore one side of space. So people, objects, and sounds on one side tend to get ignored, and the patients who have it tend to be drawn to the other side. And this can extend to things like the food on the plate in front of them. They're only food on this side and then say they're finished. It may extend to parts of their own body. So when trying to shave, they may shave this side of the face and miss out this side, put makeup on.
So you can only see from across there.
Yeah, from there to there. That's my vision.
So what's going on in the other half?
Nothing.
There's nothing at all.
Because often I've come up from this side to give you something.
Anybody can
haven't I?
creep up my left, I
And
wouldn't
he
know they
doesn't
were there.
see anything.
I can't sense them.
So if you just look at me and just point at the finger that moves, okay? Or say both of both. So which finger moves?
First one. That one.
Okay.
Yeah.
Look at me.
That one.
Okay. Look at me.
That one. That one. That one. That one. That one.
Okay. That's fine. They tend not to describe.
Notice when he did both fingers, he only noticed the one that was on his right. That's called extinction. We may talk about that as well.
The condition, to be honest. One of the most intriguing things about it is that this sort of loss of attention for one side of space doesn't leave a great gaping hole. And that's why it's very useful to contrast it when someone's got what's called a hemianopia, which is a primary sensory deficit. They can't see that side of things, and they know they can't see it. So they're constantly moving their heads like that. Whereas patients with neglect are unaware of their deficit, that they're not even aware that they're missing something because their sort of imagination space has gone on that side too.
Okay, I'll stop it there. The link to the full video is in the slides, so you can go look at it later. So what were some of your impressions from that? What stood out?
Just how he was explaining his visual, like what he could see, the patient, you know, he would just say it was nothing, you know, whenever he got to the point where he couldn't, you know, his left side, or I guess it'd be his right side. But yeah, no, and I was actually curious to what that would look like. You know, we see about 180, maybe even less, of our visual field, but is it like just a black spot like that's there?
Well, so that's what the physician contrasted his experience, meaning the patient's, with hemianopia. So that's where people will have damage to the visual system, where it looks like there's literally kind of like a hole in your visual field. And it's something that they're aware of. Like you said, it bothers them, and then they'll work their way around. Wherever the hemianopia is, they'll kind of move their head to try to get the visual field to cover the spot that's normally not detected because of the hemianopia. So those people can't sense information, let's say on the left side or parts of the left side. They're fully aware of that at all times. It's a part of their experience. So it really is, imagine just, I mean, kind of strange, but imagine just your visual scene. Imagine there's a black hole in it, sitting in some spot of your visual field. And as you move your eyes around, that black hole moves around too. Okay. With the hemineglect people, there are studies out, I'll probably mention this offhand with some of the experimental data that we have, that show that they can see in the neglected part of space. So it's not a sensory problem. They can detect, I should mention that this patient had a more extreme version of hemineglect. So oftentimes it's not nearly as bad. And you can clearly show that these people can detect stimuli on the left side of space. Using tests similar to, for example, when you go to the DMV the first time you get your driver's license, or when you renew sometimes, and they test to make sure you can detect dots on the left side and the right side. And they may have, you can have more elaborate ways of doing this called perimetry. But they test that they can actually see things on the left and right side of space. And most hemineglect patients, you can show that they actually can see things. It's not a matter of being unable to see. The problem is that sensory information isn't attended oftentimes. And so that's one of the main reasons why we think that this is an attentional It's spatial neglect is an attentional problem as opposed to a sensory problem. So what are some other things that struck you guys as you watched that video?
I thought the extinction was super interesting because I read about it in the chapter, and I think I kind of understood it, well, like through words, reading about it. But when I actually saw it, I was, I guess, blown away. Not blown away, but I was like, "Whoa, that's insane!" I don't know, that was like really interesting.
Yeah, yeah, and that's another way kind of it shows the attentional nature of the problem, because once he moved his finger, I'm trying to get this right from your perspective, like
Mhm.
towards the midline, then he could see this finger when the physician moved it, or this one.
Yeah.
When both, he doesn't say you move both. He says you move this one.
I know, so I was like, "What the heck?" I would just like to understand it a bit more. That it was interesting.
Right, right, yeah. So the basic idea behind extinction is that when you have two stimuli that are basically competing for attention, the one that's towards the right will win out to such a degree that people may not be aware of the other stimulus.
Okay.
And this works, by the way, just not for the visual field. You could tap their hands.
Mhm.
Same thing would happen. You can tap their left hand and they may say, okay, I understand. I noticed that. You tap the right hand and they notice that. You do them both at the same time and they only notice the right hand being touched and not the left.
Get it out. Cool. All right.
Yeah, so other thoughts?
He was particularly hard to hear out of the video. Like his communication was, to me, it seemed muffled. And so, does that have any, you know, spatial neglect? Does that, have any effects on that, on communication?
Yeah, I think a lot of this I would chalk it up to them being British and the sound guy. So typically, no. With a clear-cut neglect syndrome, and again, the people that are the patients that are studied for scientific purposes, usually you want it to be clear-cut. So you can certainly have people with lesions, especially after stroke, that have more than one problem. They may have attention neglect. They may have some motor problems. That's very common, actually. They could have some language problems as well. So it's possible. With him, I don't think it was. I don't think that was. Well, they didn't mention. I saw the whole video when I first chose this. I don't remember them mentioning other problems that he had. Although, when you watch it, correct me if I'm wrong, but I don't recall there being other issues. It was pretty focused on neglect, which is why he was such a good example to show that it was very severe. Because oftentimes you won't get he says, you can sneak up on, you can come on my left side, come up to me on my left side, and I won't know you're there. That's, oftentimes that's not the case with people that have milder versions of neglect. They have some sense of what's going on the left side, but they're certainly still biased towards the right in terms of attention. He had something, these classic anecdotes, which is, the people with, when they're eating, if you have food all around the plate, they'll eat the food just on the right side of the plate. And I remember one neurologist, Ken Heilman, who's also kind of famous for studying neglect as well as lots of other things. He was telling us about, how he would do this, just that. He would go to the cafeteria with the patients, and he would just turn the plate. And from the patient's perspective, this food kind of just suddenly appeared on the right side as you rotated it. So yeah, so these things really, if you have neglect that's persistent, because a lot of times these neglect symptoms will occur in the acute phase of a stroke. Somebody suffers a stroke, and then of course people usually get better to some degree. It may not be that much, but some people can recover, almost fully, as best one can tell. And so as part of that recovery, the neglect may go away or may get very mild. But if it doesn't, then it can really make life very difficult for them. You can imagine not being aware of half of the space. So this guy, he was having his life, although it's a really cool, thought-provoking problem, you can imagine what it'd be like to have to live like that. That wouldn't be that much fun. All right, so let's dig into this and get some specifics here. So this was I thought this was interesting as far as this idea of recovery and what can happen. This is actually perfectly makes the point that this Roderscheit was an artist, and so he suffered a stroke, and he did these self-portraits, and it goes more or less clockwise as a function of time after his stroke. So just a couple of months after the stroke, notice here he has a full sheet of paper, but he's drawing mainly on the right side of the paper. And he didn't, for whatever reason, he didn't draw a whole lot here for the 2 months after his stroke. Now he's starting to take up more, the painting is taking over more and more, encroaching more and more on the left, but there's still a whole lot of white space here where he didn't paint anything. And then after about a half a year or so, now he's starting to use the whole space again, same thing over here. So this is showing that, kind of graphically, how his artistic expression is influenced by his hemineglect. And you'll see things like, they showed this, an example of this in the paper. Let me get I'm sorry, in the video, where they show people, here's a flower. And they're not even really doing this from memory. Often they'll just kind of say, okay, here's a flower. Why don't you draw something like that? And they shift their attention a little bit to the other side of the paper, and look what they come up with. They put all the petals on the right side of the flower. Over here, the stem, the leaves, they also put that on the right side and not so much on the left. With the clock, I think the clock that patient drew in the video, he had the right numbers here, went from 1 to 6, but he just didn't put the rest on the left side. Sometimes people will cram all 12 numbers onto the right side of the clock. So that's interesting because it shows they're aware that there are 12 hours in the day. It's not like they were unaware that it's the day, or I'm sorry, the half a day, 12 hours AM and PM. But they wanted to get them on the clock, but they only kind of had access as far as drawing goes to half the side, so they put them all on the right side. So you'll see this sometimes. One of the more common ways of trying to gauge the level of neglect is something called the line bisection task. And so the way this works is you just give the subject, the patient or subjects who don't have brain damage, a line, and you give them a pencil and say, okay, put a scratch in the middle of the line. And what you get with neglect patients is that the true midline, so you can objectively measure how long the line is and know exactly where the middle is. They'll mark the midsection farther to the right. So the implication here is, from this patient's perspective, the middle of the line is here. That means the whole line is about here, where I'm pointing the laser at. And then this is what they're perceiving as the line. And then this is where they're putting the middle, consequently. But we know objectively, the reality is the line is much longer. So the midline should be farther to the left. Now, another way you can study this in the lab and get a much more precise sense of what's going on in terms of spatial cognition is by rolling out our usual cue target endogenous attention condition, right? So we give them a cue, in this case an arrow, and say, okay, expect a target on the right side of the screen, and then you have a target there, and then you press a button. And then we have our usual valid trials where the cue tells you correctly where the target was. Invalid trials, the cue lies to you. It says it's going to be on one side and it ends up on the other. Or neutral cues where you don't give the patient information about where to expect the target. And this is one study. It's a classic study. It's a little messy, which is one reason why I wanted to show this to you, is to kind of, this is the type of real life data that researchers deal with to draw conclusions that we're talking about in class. And so this is showing that cue target interval, right? We talked about the importance of the time between the cues and the targets, and that it takes a little bit of time to orient endogenous spatial attention. So typically what you get is that with short cue target intervals, reaction times are slower, and then they speed up with longer cue target intervals. So we see that here with the healthy controls, as well as the patient. And the patient, and this, I think this was actually an average of several patients, They were very similar to the controls, and the controls usually for the patients with neglect, stroke is well, not probably, it is the most common reason for neglect. And people who get stroke are more likely to be older. So what you do with your controls is you don't run a bunch of college students, you find people who are older that are comparable to the patients in terms of age. Typically you'll control for their sex and gender. And the easiest way to do some of that, also for non-specific things like socioeconomic status, healthcare, things like that. You can get their spouse to be a control, or you can get one of their friends, their brothers or sisters, that sort of thing. So a lot of times these experiments are kind of a family affair. You have the patient and then some people that are in the family of the patient, you can bring them in as good controls. So the main result here, I guess the main set of results, is that these patients were, they're not as bad off as the patient we saw in the video. And they were remarkably similar to the control subjects for cueing, where the cue was on the same side of space as where the lesion was. These are patients with lesions in the right parietal area for the most part. And when you cued them to shift attention to that side of space, they were very similar to what you'd expect with controls. And it even worked if you cued them to attend to the left side of space. So this adds in a complexity here, right? It's not that the patients are never aware of the left side of space. If you cue them to attend to the left, they can do so. And again, these are milder patients versus the one that we saw. It looks like he has a great difficulty attending to the left side of space under just about all conditions. So if you cue them to the left, they can shift attention to the left and show a relatively normal response here as far as reaction time goes. And if you cue them to the left and then the stimulus shows up on the right, they can respond to that pretty well as they can respond to that as well. The place where they fall apart is when you cue their attention to the right and then the stimulus shows up on the left. So this is an invalid stimulus that's contralateral to their lesion, right? So the lesion is on the right, the target is on the left. Under those conditions, that's where they fall apart. And they fall apart in the sense that it takes them a long time to disengage attention from the right and shift it over to the left, which is presumably what's needed to respond to these stimuli that are on targets that are on the left side of space. So this is illustrating some of these nuances where it's possible to attend to the left, but if you're attending to the right, attention tends to stick to the right. And if the target shows up on the left, then it takes more time to disengage or unstick attention from the right side of space and then move it to the left side of space. And that's the way a lot of people think about attention neglect. It's really this strong bias towards having attention on the right side of space. And when the person is just going about their everyday life, the default mode is to have attention sort of tethered to the right side. And then it's harder to get attention to shift to the left. So that's why, for example, some of these the studies where you do extinction, for example, it's less likely to kind of spread over to the both fingers that are being moved at the same time. That's one instance where this tethering effect can play out, that you only notice the one that's on the right side that's moving. Does all that make sense? All right. So there's still this issue of, well, you may be thinking, all right, but these are still, they're tending to sensory information. And we have this contralateral influence of, okay, stimuli that are on the left side of space. If those are the ones that they need to reorient to in valid trials, that's where these subjects fall apart. I still suspect there's something about the visual system with this contralateral organization of the visual system that's feeding into some of these attentional deficits that we're talking about. So is there a way to really, in a more convincing way, show that this attentional, that these neglect symptoms are really an expression of an attentional problem, as opposed to some complex, high-level visual processing problem? Well, enter Bisiach and Luzzati in 40 plus years ago, and they said, okay, fine, how about this? We'll do an experiment where we're not even going to have people responding to stimuli at all. And so what they did was they used their mind's eye. They didn't use their actual eyes. They used their mind's eye, their imagination. And they wanted to see whether these similar neglect symptoms in terms of the left side of space would be evident when people are imagining things, using their memory to think about a spatial layout. So what did they do? So this took place in Milan, Italy. And in theirs, as with a lot of Italian towns, everybody's familiar with the piazza, the town square. That's where kind of it's like the living room of the town where people like to hang out. So everybody knows about the layout of the piazza. And so what Bisiach and Luzzati did was, in their clinical office, they're not in the town square. I don't know where their offices were, but they weren't in the middle of the square, that's for sure. And they said, all right, to the neglect patients, imagine you're standing in different places in this piazza that's very familiar. Describe to me what you see, right? So they're asking them in their imagination, what do they see there? So this gets it, and I'll show you in the next few slides kind of how this would all work. So they're getting it, is there these attentional issues, these problems with attention, if indeed it is an attentional problem for neglect? Is that expressed even in your imagination, where you're using memory representations in your mind about the layout of this piazza? And then what they did was they asked them to imagine they were standing at different locations within the piazza. So imagine standing at the north side of the piazza, for example. Okay, now imagine you're standing on the south side. And you can do this, just think back to when we went on campus regularly. You can think about just various kind of now I'm even blanking on the name of the main kind of our own little piazza where the food court is. And imagine you're standing at the psychology building at your back, MH, all right? You stand on, and you would have the food court would be on your left. Now imagine that you're standing on the other side near the Flawn Hall Science Building. Now the food court would be on your right. So that's what they did in this experiment. So the reference frame here is it's egocentric. It's relative to kind of where you happen to be standing on this. And that can be distinguished from an allocentric reference frame, which would be the north, south, east, west. So the north part exists regardless of where you happen to be standing, right? It's relative to a larger reference frame like a map. So this egocentric reference frame would be relative to where you're standing. What do you see? When you stand at a different location, what you see is different as well. So that means it's an egocentric reference frame. So here's an overhead view of the Piazza del Duomo. The Duomo is the cathedral over here on this side. And then so they imagine, okay, view one, you're standing in front of the cathedral, you're looking out onto the town square here. What do you see? So if indeed this neglect is the spatial neglect applies to memory, you would predict they would describe what's going on the right side as well as what's in front of them. And they wouldn't talk about what's over here on the left. Now imagine they move over in their mind's eye to this second view over here from the opposite direction. Now they should be talking about this part of the piazza, which is now on their right in their mind's eye, and then neglect and not talk about things that are on this side on the left. And this is just showing out, I take vacation pictures and this just shows what happens when you're a scientist and you're a professor. You just think you're hanging out, just having fun. You go, oh, this would be good for class. And you start taking pictures. Drives my family nuts. At any rate, so here's a picture of what they would see on the piazza. The church is behind them. And over here, there's some offices. There's a galleria over here. I don't know, there's a McDonald's up there. You see it. There's a statue in front of them. That's the sort of things that they could describe. When they're looking from the other direction, now over here, here's the church, the cathedral in front of them. There's I think the post office was over here and some other stuff. And this is showing that galleria that everybody would know about in this town. And this is showing whatever the post office and everything over there. And there's the gallery. Okay, enough of the vacation pictures. Here's the results. It fit the prediction, oddly enough. So when they reported standing on wherever they happen to be standing, they reported what was in the town square to the right of them and in front of them, but not on the left. They imagined they were standing in a different part of the piazza. Now they'll describe things that they failed to describe when they're standing at the opposite end of the piazza. So this tells us a couple of things. One, they had a complete memory for everything in the piazza. They didn't forget one side. It was accessible in memory. But when they imagined themselves standing at one location, one vantage point within the piazza, they didn't spontaneously bring up the memories about the things that were on the left side from that viewpoint. And again, there was no stimuli whatsoever given. They're just sitting in the office, right? So there's no visual information about the piazza to be processed in an unusual way. This was all in their memory. So it's kind of weird, right? That this neglect could spread not only from the outside world of what you see or what you hear or what you're touching, but it can spread and shows itself, rears its kind of, ugly deficit to information in memory. Pretty weird. And just buckle up, it gets weirder. So we're just getting rolling with this. Okay, but is that all reasonably clear? All right. So you can show this deficit also just on eye movements. And one of the important reasons why it's helpful to look at eye movements is, one, there's that premotor theory of attention that we were talking about, that attention and eye movements are normally closely coupled to one another. The other is that people usually don't think about their eye movements. It's an unconscious phenomena, but we do this all the time. Obviously, when you read, you're moving your eyes around, but just when you're hanging out, looking around in everyday life, your eyes are moving back and forth in the sampling the visual scene about 2 to 4 times per second. These are saccades. I think we talked about this before at some point. So you can simply ask, all right, what about the saccade sampling of these patients with hemineglect? Are there differences there? Because you could say, well, maybe the sampling of visual information is unaffected by this. Maybe this is a high level attention problem, but visual sampling may be unaffected. On the other hand, does the attention deficit drill down to the point where it's controlling eye movements as well, or biasing eye movements as well? So these are two clear possibilities that can be tested. So of course, people like Berman went in and said, well, let's test that. And this is what they got. So imagine that the x-axis here is the horizontal visual angle, so 25 degrees from midline, left side, right side. They're looking at some pictures, I think. And they're moving around their eyes to sample the scenes. And what you have here, the bigger the circle, that means that their eye fixated at that location for a longer period of time before moving to a different location. But the key result is super obvious. For the control subjects, they looked on the left side and the right side of the picture in terms of saccades, about equal amounts. And they sampled the up and down direction as well as left, right pretty well. So they really canvassed most of the canvas. But for the neglect patients, look what they did. They sampled mostly on the right side. Up and down was okay, by the way. So they sampled the full range of up and down. Barely went past midline, and even here on the right side, they tended to avoid midline, mainly kind of stay here well into the right side of the visual field. So the clear result here was okay, this neglect phenomena, it also expresses itself with the way people search visual space using their eyes. All right, so here it gets a little weirder. So vision is not just two-dimensional, right? We've got depth involved as well. So we have their results showing a double dissociation for neglect for things that are close to the person, near parapersonal space, and things that are farther away. And so this is just one of several studies along these lines that show the double dissociation. I won't show the full double dissociation here. So this is a patient with, again, a right hemisphere lesion. The neglect was on the left side of space. I should mention, so people occasionally will have lesions in the left hemisphere, and the neglect will be on the right side of visual space. So this contralateral mapping of the lesion location and the side of space that shows the deficit seems to be contralateral for both possibilities. But like I said, for the most part, neglect is a right hemisphere phenomena. occasionally I looked up, there are a few case studies showing that it's possible to have neglect with lesions on the left side of the brain and neglect on the right side of space. But the overwhelming majority of cases are with the right lesions, left side neglect. All right, so for this person, okay, I also mentioned you can have neglect for near objects and better for far objects. So here's our double dissociation that I mentioned. And then this is parapersonal spaces, things, parapersonal just means things that are around you that are within reach. And once you get beyond that area, then you get to, that's where parapersonal space ends. So Berti and Frasinetti, as you can see, there are a lot of Italian names that they really, Italian researchers, there are a lot of really important people that studied brain damage and did these neuropsychology studies like what we're talking about to figure out what it means in terms of cognition.
Do you think that's because they were the house of basically philosophers during the Machiavellian period? I'm totally not quoting that correctly, but Italians love to think.
Yeah, they do, and it's funny. I have a lot of friends from Italy, and I've collaborated with some of them. And boy, so that, it's a stereotype, but that doesn't mean it's totally wrong about Italians being pretty passionate folk. And it was really funny just doing science with these Italians. And you write up your results in a paper, you send it to a journal, and then they give it to reviewers. The reviewer's job is to criticize it. And then they send their comments back to the researchers. And then if it's not rejected, you can respond to the comments and then send it back to the journal. Oh man, you have to write a letter back to the journal responding to these critiques. Oh man, they were just going crazy with the reviewers. These are the most evil reviewers ever. Oh, I hate these people. And I'm like, they're just criticizing our study. It's not that big a deal. They actually kind of liked it. Oh no, these are bad people. It was just off the handle. It was really fun. So yeah, at any rate, I digress. So these Italians doing good research here. So what they did here is they used the line bisection test, right? So you have a fairly sensitive quantitative measure of the degree of neglect. And the clever thing that they did was they had people bisecting lines that were either close to them in parapersonal space or far away. And they had them use either a pointer, like a pen, basically. And then here they had a pen that kind of with a stick, or they can use a laser pointer. And so they had line bisection close to them, like on a piece of paper. You can just use the your hand to do that, or you can bisect farther away using a stick that would literally be longer and connect to the paper and scratch it, or you can use a laser pointer, where you're not physically, it's not a tool that's physically touching the paper, but you can still do the line bisection by pointing at the wall, and the researcher can measure where you're pointing the laser pointer. So one is a tool that's attached to the person. The other has this, the laser goes through space. It's not really a tool in the same way. Why do this? Because when people were doing this bisection errors, so worst performance is up, better performance is down. When they were pointing far away with the laser pointer, they didn't really have this neglect. They had a neglect for near space, parapersonal space, whether they were pointing or whether they were using the stick. It didn't matter, they had the neglect. The cool thing here is when they were pointing far away using the laser pointer, they didn't have neglect, or at least it was very mild. Percent bisection error, that's close to what you would get with controls. But you give them a stick that's long, that goes into the far space, the neglect goes with it. In some ways you can think about it, I don't think this is too much of an exaggeration. Imagine the attentional deficit, I shouldn't say, the attentional hemineglect is restricted to near space, but when you give somebody a physical stick, that attentional neglect spreads along the stick and goes out to the end of the stick in far space. Pretty wild. But there's a literature on using tools and how they can literally kind of physiologically, if you use a tool, especially if you use it often, that tool kind of becomes a part of your body. And so a similar phenomenon may be going on here, that tool is sort of an extension of the person's hand, and the neglect is around the person's body, and that neglect can kind of spread all along the length of the tool. In this case, it's a stick. So it's pretty wild, but it shows kind of this high level abstract nature of this attentional neglect, that it can take into account something like holding a stick, and that attentional problem can kind of flow along with the stick. And it was a nice control here using the laser pointer, where you don't have that connection through space. The laser makes its way to the far wall, but it's not really a tool that connects the person's hand all the way to the far wall. And when you do that, then you don't get the neglect. So pretty wild. I think we can do one more. Yeah, I think we can get this in. All right, how about this? Let's go in the realm of words. And we probably mentioned this in passing, but I know I didn't emphasize it, that various types of cognitive representations exist, right? You can have spatial representations, you can have sound representations, you can have representations of the sounds of words. So literally the sound houseboat. And you can also have orthographic representations, which is the written word. So orthographic representations relate to letters. They represent the letters that you're seeing. So what about if they're coded spatially, right? We see all these other aspects of spatial coding, like space and imagination, as we talked about with the piazza in Milan. What about orthographic representation? So Karamazza, again, another Italian, he was actually one of my professors in graduate school. He and R.G. Hillis did an experiment where they presented compound words to a patient with neglect. Again, right hemisphere lesion, left-sided neglect. And they were asked to spell the word that they saw. And they presented these relatively fast on the screen. So they didn't keep it there for long where they could move their eyes around and really scan the word. They would just kind of flash it long enough to appreciate what the words were, but not enough to really, move their eyes around too much. So they had to spell what they saw. But what they did was they presented the word vertically sometimes, and people with a little bit of practice, you can do this reasonably well, name the words vertically, and then also backwards. This takes more practice, but again, it's doable. It's kind of weird, but it's doable. So here's H-O-U-S-E-B-O-A-T. Why do this? So the hypothesis was that the word can be represented spatially, that there's a left side of the word and a right side of the word. The house part is on the left and the boat part is on the right. What about neglect? Well, it turns out as you move this word around in all these different directions, whether it's in normal left to right spelling, right to left spelling, or vertical, people would only say the second half of, or this patient would only say the second half of the word. So if they saw houseboat and they said, okay, the researcher said, what did you see? They would say boat, not houseboat. And the reference frame seems to be the word itself, because notice here, the house part of houseboat is physically on the right side of space from the perspective of the patient. But from the perspective of the word, house is on the left side normally, right? As you normally spell house and then boat. The house part here is in the right side of visual space, but the left side of orthographic space. And under those conditions, they would neglect this part of the word. So it shows that the neglect can spread to the orthographic organization of the word, not just the physical visual space. And then here, when it's vertical, there is no left, right? It's just vertical. But even under those conditions, they would say boat, for example. They had a whole bunch of compound words, by the way. It wasn't just houseboat. They had a whole bunch. I'm just using this as an example. And again, they would neglect the house part of the word. So we can add to our list of strange ways that space can be represented in neglect. In this case, it's orthographic space, and you can get neglect to that as well. So any questions about this experiment before we break for today?
I was just thinking about how houseboat, when it's presented initially, like as it should be, I was thinking, perhaps like boat had been like, I don't know, put into that working memory so that it orients itself all around, and so that's why, HOUSEBAOAT is the way that it is. because that part that doesn't have the lesion recognizes that was on the right side. It should maintain its right sideness, as it moves around. But that up and down, like in the middle houseboat, like that's incredible.
Yeah, and that's you're very perceptive about that, because there is a memory component to all this. So it really is getting it, not just spatial information, but how spatial information in the form of the words is also represented in short-term memory. Here, the short-term memory would be on the order of a second or two or so. It depends how long it takes the patient to respond, but about a second or two or so. But nonetheless, it's in short-term memory. And there are some data out there. I don't want to get off on too much of a tangent, but this was something that I talked about in the paper that's coming out probably in a few days. That short-term memory, there may be a spatial organization to short-term memory itself. There may be so they may be also kind of tapping into that in these experiments.
Wow.
Yeah, even if it's just for words, right? So you don't have to be remembering spatial information, but nonetheless, in short-term memory, there are these spatial representations kind of kicking around in the background. Okay, any other comments or questions?
I was also thinking about what the word left, like the proposition for the word left and right. Mm-hmm. Like how could you study that the idea going, they know if a lesion occurred because of a stroke, at some point they must have been able to perceive the left side or whatever side that is now in a deficit. So if you presented words that orient towards that field, does that just doesn't make the connection, or is that just no longer there anymore?
Right.
Just thinking.
Yeah. Well, it's one of these with neglect. There's a lot of sometimes this and sometimes that, right? And so I gave you some sense at the beginning of, well, sometimes they can see things on the left, but they may not recognize them or attend to them. So this is one area that's for practical purposes, for rehabilitation, people are interested in is, can we capitalize on some of our long-term knowledge and habits to encourage attention to spread more over to the left side of space, or not be anchored so much to the right? And so some of what you're talking about, especially when you think about just simple words like left and right, could that be used to help orient attention more to the left, for example? Can you set up a situation that's more likely to attract attention to the left side of space? And so people have experimented with this approach. If you can set up, and I don't know if people have done this, I would imagine somebody has, a tablet where you can try to cue attention or reflexively use exogenous attention to shift attention to the left side of space, so people are more likely to read and notice things on the left side of space. It would be one approach. I like I said, I don't know if people have done that, but I would be surprised if somebody hasn't. So yeah, capitalizing on kind of what people can do when you're looking at people with brain damage is a really important line of thought for rehabilitation. And since we're talking about people with stroke, what happens is we presume for most of them, they had a relatively normal brain until a stroke destroyed parts of it. And so you have to kind of ask, well, what can we use that's preserved, that they, especially long-term knowledge, which is resistant to a lot of these brain damage. It's hard, for example, to get long-term memories to really go away. With Alzheimer's disease as an example, there's a whole lot of neurodegeneration that takes place before people really lose a whole lot of long-term memory. So yeah, thinking about people with strokes where the problem is with attention, can we use long-term knowledge and memory to try to improve the quality of their life? Yeah, and the answer is yes and maybe, and people are working on it.
So for
yeah.
if a person with this kind of lesion does that test where there's like two different images, one presented to the right eye and one presented to the left, do they still have that flip-flop thing, or do they ignore the left eye, or is it more of a spatial thing? And it's, just wondering about that.
Yeah, that's a great question. I don't know. I don't know, but if you're interested in it, if you look it up and send me an article or something, I'd be glad to. I think that's something we could talk about on Tuesday. Because either way it goes, I have some sense of what, if I had to make a bet, what would be going on, but I don't want to say it right now just because I really don't know.
Okay.
I'll make a note here. If you don't, Lisa, this is Lisa, right? If you don't send something to me, I'll probably poke around and look at it. Because I think that would be something that would be good to talk about. In addition to the ADHD, we haven't talked about that yet. So on Tuesday, we can wrap that into our discussion too. Yeah, that's a really good question.
Are you familiar with parallax in like astronomy?
Yeah.
And so like, that's why I was thinking about the ruler, and kind of Lisa kind of honed in on it. Whenever you can kind of close your eyes and things orient, you know, to your open eye. And the way that the light pointer doesn't do that for you, but the ruler will. That'd be pretty cool to hear about, man.
Oh, yeah, I don't recall. I read the paper a while ago. I don't recall them thinking along those lines. We're doing any kind of controls, or at least get some sense of, so that there's sensory, yeah, the kind of depth perception, and is there a sensory angle to this? Yeah, I don't recall them doing that, but it's a good point. All right, we'll leave it there, folks. Thursday. Have a good weekend. I'll see you on Tuesday.